I'm Trond. I'm coming from Typesafe. I'm going to talk about Scala. This talk is called Scala in Action. It's introductory Scala talk. So if you've been playing a lot with Scala already, this is probably not so interesting for you. In that case, however, we have advanced Scala training tomorrow and the day after in cooperation with Virtus Labs, our partners here in Poland. So I think there's still a couple of spots left there if anyone is interested. So this is a presentation with no slides. Okay, it's only coding. Actually, before this weekend there were 2 slides in this presentation, but I replaced it with some ASCII arts. So that's what I've been doing this weekend. Yeah, so I think we should just get started. What is your knowledge about Scala so far? Has anyone tried to write a small Hello World program in Scala? Quite good. Is anyone working with Scala on like a hobby project? A couple. Full-time work? A couple of guys as well. Is the hobby project the same as the work? No. Okay. Cool. Okay, this is good. Who's coming from a Java background? A lot of people. This is good. This is good. So I have some Java code for you to analyze. So I'm going to blow this up a little bit. Okay. Can you see? Yeah? So my question is to you, what is this class doing? Or what is this code? It's boilerplate. Yeah, very good. It's boilerplate. So we have a Java time class here. We have a couple of private fields. You see that they are final. We have a constructor down here. So we set, and in this constructor we set the initial value of the 2 fields. So hours, 2 minutes, and then we create the s-minutes field as well. So this is like a representation of the total amount of minutes. So hours times 60 plus minutes. Then we have getters. Okay, and we have a minus method that allows us to compare 2 times. Okay, it's just returning this as minutes minus that as minutes. And to make this play nice, to be able to put it into collection and compare things, we also have a equals method, which is quite boilerplatey as well, and a hash code. Okay. Good. So I'm going to try to create this class in Scala, and we're going to see how we can do that. Okay. So the first thing I'm going to do is to create a new class here. So I can create a Scala class, and I will call this Scala class time. Okay. Okay. So this is good. And what is really nice about the Scala ID is that you have something called a worksheet. Okay. So I can experiment with the code I'm writing, and I can get immediate feedback about what I'm doing. We call it experiment-driven development. So I'm going to create this worksheet here. I have one already. And here I can create a new instance of this test class. Wait, did I put it in the right project? New time, sorry. Okay, so this is good. I can also assign this to a variable, okay? And in Scala I can do that by using the val keyword. So val stands for value, and it's an immutable variable. So we can call it t for the time being. So val t equals new time, okay? But this doesn't give us so much, okay? We're not quite there yet. So we need to instantiate this time. When we instantiate it, we want to instantiate with some values for hours and minutes, right? So how do we do this in Java? We had a factory, we had a generator, right? And in Scala, we can get away with, we do it in a different way, okay? So instead of creating generators, we have class parameters, okay? So a class, like a method, can have parameters. So here I will say hours is a type int, and minutes is also type int. Okay. You can also notice that hours, so the type and the variable name has changed, or the parameter name has changed place. And this is basically to make it easier for type inference that we're going to see a little bit later. Or we can see it here actually. So here we see that I'm writing val t, and the Scala compiler is automatically guessing that this is of time t. There is no need to specify this, even if we can. Okay, this is no longer compiling. Why is that? It's because we added class parameters. Okay, so what time is it? 11:06. Okay. Yeah, so we see here that this compiler is able to infer the type for us. So this variable is either we specify it or we don't specify it. If I try to specify that this should be a string, however, the compiler would complain. Okay, so this is just like you expect it to be from Java. Scala is a statically typed language with strong static typing. But it has type inference. This means that you don't have to write the types all the time. Okay, let's move on. What more did we have? We were able to access these. Oh, maybe something else you're wondering about. What if I wanted to do something else in the constructor? Okay, I don't know, maybe verify that hours and minutes, or that the hours is less than 24, for instance. Okay, when using class parameters, or in Scala in general, everything that is in the body that is not fields or methods, it's part of the primary class constructor. Okay, so if I want to add something to the class constructor that I want to be evaluated when we are starting, I can write it here. So I can require the hours to be bigger or equal to 0, and hours to be less than 24, for instance. Okay, hours not valid. Okay, we can test this out here. So if I add, for instance, -1, we will see that I get a legal argument exception. Okay, so here we see hours not valid. That allows us to see another feature that is new in Scala. What if I wanted to give the user a little bit more feedback here about what is going wrong? Okay, so I could say hours not valid was, okay, then I could do this clumsy string thing here, say hours, was hours should be between 0 and 24. Okay, but writing this is a little bit clumsy, especially if you're writing multiple times. So in Scala 2.10, we have something called string interpolation. So we can write something called interpolation strings. And here we can add variables directly inside of the string. So no longer need to do this. And then we can reference variables on the outside using the $sign. Okay, and this is very handy. It's in the beginning, I felt this was like, not so interesting. But when you use it on a daily basis, it's really nice, actually. Okay, so that's good. Let's move on. You can also create auxiliary constructors. Okay, so if you want to have a different constructor, you can do this by creating a method with the special name this. Okay, so creating a method in Scala, you use the keyword def, okay, then the name of the method, so in this case this, and let's say hours, type int, and the first thing we have to do afterwards to make sure that the instantiation of the class is correct and sane is that we have to call another constructor. So in this case, the primary constructor, so hours and minutes. Oh, minutes is not defined, so we can put a 0 here. But there is actually a better way to do exactly this, because in Scala you can also provide default arguments, okay? Default values for the parameters. So here, for instance, I can add 0 as defaults for both hours and minutes. And now I can go to my test case, and I can create a new time without any parameters. And the hours and the minutes here. Okay, question? So it's possible. You have to have them, if it's going to make sense. You have to start at the end. Okay, so you typically put the default values at the end. Okay. But
you can use names for parameters.
Yeah.
You can make the parameters when you call them.
Yeah. So here's an example of that. So here, for instance, I'm only using the default for minutes. But if I wanted to use the default for hours, I can use the named version. So minutes equal 4. Okay. It's a pity we cannot see it here. Well, we could override the toString. Well. Anyway, we're going to see how to do this. Then afterwards, we also had a field. Okay, so I said that we can create a field using the val keyword. Okay, as minutes. And this is going to be hours multiplied by 60 plus minutes. Okay, so now I can say t as minutes. And we will see that this is equal to 4. On the other hand, we cannot really access hours and minutes, okay? Because hours and minutes, they are just class parameters, so long. What we could do, we could define them like we've done here. So val hours equals, well, we'll get a name collision here. So hours L equals hours L, for instance, okay? But this is a little bit clumsy, okay? There's a better way to do this. Okay. The only thing we have to do if we have a class parameter and we want to make it, turn it into a field, is to add the val keyword here. Okay. This turns this class parameter into an immutable field. Okay. Let's do the same thing for the minutes as well. So this means that we can now access both the hours and the minutes of this time. Okay. Good. What more did we have? Let's see, the Java time class. So we have the fields as minutes. We have calculated as minutes. Okay, we got getters and setters. So in Scala, in Java, why do you have getters and setters? Why do you want to use it?
You can set final.
I'm sorry? Oh, final. By definition, when you're using a val, that's an immutable variable. So it's what is translated to on the JVM is a final. Okay. So if you want a variable, okay, in the normal sense that you can mutate, use the var keyword. Okay, and you can use that var keyword here as well. So I could say var as minutes. And now I would be able to change the value here. So I could reassign as minutes equals to 34, for instance. Okay, changing this back to a val, however, makes this illegal. Okay, so when you're using a val, it's final, and we always recommend you to start with vals. Okay, and we're going to see that Scala is very expression-oriented, so it's very easy to program using vals in Scala. Okay, yeah, so we're talking about getters. Why do we use getters in general? What is the big idea behind using getters and setters in your Java beans? Contract, yes. You want to be able to modify the inner parts of your program, right, without necessarily destroying for the user of it. Okay, so if you have a big system, you want to be able to modify the implementation. Okay, so maybe in the beginning this was just a field, but later on you want to change it into being a method. Okay, and that's why we have getters and setters. Then afterwards, there is also some frameworks that needs getters and setters, but let's not get away from this. In Scala, however, when you're creating a val, this is creating a private field, and in addition to this, it's creating a public getter method for you. Okay, so later on, you can override this getter, okay, without having to change the users of your library, for instance. Okay, so you got what you call the uniform access principle implemented for you directly in the language. Okay, that's saying that you should be able to access a stored and a computed value in the same way. Okay. Okay, so we don't need getters and setters. What is left? Minus method. Okay. So we want to create a minus method. So we use the def keyword to create a method, minus. We can provide one or multiple parameter lists, okay? And each of these can have multiple parameters. So minus, let's call the other time that we're going to compare with that. And now actually this, optionally we can specify the return type. The Scala compiler is also able to infer this for us if you don't specify it. And I can write this as minutes minus that as minutes. Okay, so if I create a second t here, val t2, new time, well, let's say 1 here, and 30, and t dot minus t2. Gives us 34. Okay. What you can also do in Scala is that you can use something, if you have a method with exactly one parameter, you can use it in what we call operator notation. Okay? And this basically means that you're taking away the dots and the parentheses, like this. So then you have two operands and an operator. So t is the first operand, t2 is the second operand, and the minus, it's the operator. Okay, and this is doing exactly the same thing as we did before. And what is also nice in Scala is that you can give the variable names. It's not as limited as they are in Java. So if you want, we can specify a symbolic minus method for this time. Okay, and we can say we just delegate this to the other one that we already created. And now we can actually say t2, t1 minus t2. Okay, that's quite neat, isn't it? Okay, what more? We also had the boring equals and hash code. Okay, in Scala there is a very quick way to add equals and hash codes if you have a class with class parameters. If you just care about class parameters, as we do here. Okay, and that is to add the case keyword in front of the class. Okay, and then you got equals and hash code implemented looking at the class parameters. So if hours is equal and minutes is equal, 2 times will be equal. Let's try that. T equals T. It's true. T equals new time 1,4. It's also true, even if this is a different instance. So equal equals delegates to the equals method that you specify. What more? I think that's all what I want to tell you about. You also get a couple of other nice things when you use the case class. So for instance, you get a factory method that allows you to create a new instance without the new keyword. You could copy. So I can, for instance, say t2 copy. And I can specify that, let's see. Yeah, t2 copy hours equals 5. If I just want to change the hours and I want to keep the minutes, I can do it like this. Yeah, and we also get a nice 2-string implementation here, okay, which is using the name of the class and then afterwards the toString of each of the parameters. Okay, but we can do better with the toString, okay? This is also nice. The override is mandatory when you're overriding things. So override def toString equals. So have you been formatting? What if I wanted to write an hour like this? So with zero padding, etc. So we can specify this string formatting, right? Anyone seen this before? %02D and format, and I pass in the hours and the minutes. Okay, let's see now what's happening here. Ta-da! The problem with this, however, is that this formatting is happening runtime. Okay, so if I made a small mistake here and this toString method wasn't called that often, let's say I create another field just to illustrate this. So equals times hours toString, and instead of passing the hours here, just passing h. So this compiles, okay? But when I'm re-evaluating this, runtime exception, okay? Bad thing, you don't want this to happen in production. So you can also use the string interpolation in this case, and you can use what we call a format string. And in this case, I can say dollar here, as I did earlier, $hours, %02D, $minutes, %02D. Okay. Reevaluate, and it's like before. However, if I happen to do the same mistake as earlier, compile time exception. Okay, so this is using the new macro feature in Scala 2.10, and it's quite nice as well. Okay, let's get rid of this. Any questions to this time class? Yeah.
What about the syntax? There is no semicolons, no dots. You are just writing with carriage returns and spaces. Only white spaces to format the whole program. And what about I don't know tabulators? Does they have a special meaning as well?
No, so actually Scala has what is called semicolon inference. Okay, so the Scala compiler is able to infer where the semicolons should be placed. Then afterwards, so you can write semicolons to separate lines of code. This is valid in Scala. You're allowed to do it. I can also write here, for instance, dot like this, plus, if you like. Okay, so this is just method calls. Everything is an object in Scala. So this is just method calls. But this is ugly, right? We all agree on that this is ugly. It's not the way it should be. But here, for instance, that could make sense. But there is no need to take any special consideration. Only, so what will not work is this. Okay? If you write it like this, as minutes, the plus as minutes is just going to be plus of an int, and nothing is going to happen afterwards. Right? So you always have to put, you have to use the trailing operator. Okay? If not, it won't work. But apart from that, you can tab like you want. So my code is nicely indented because I'm using automatic formatting. Any other questions? Okay, let's move on. Next thing I want to talk about is collections. Okay, So Scala has a very nice collection library, and I can create a list, for instance, like this. Oops. Okay. So this is by default an immutable list. I can assign it to a value L. Okay. Now there are some common operations that you all know about. So I can ask if this list is empty, for instance. I can say get the size of this list. I can sum all the elements of this list if I want. So here it's a little bit of magic happening behind here. So what happened if this list wasn't of elements that could be summed, for instance? But anyway, I can take the first element of the list using the had method. Okay, this will give me the first element, and then you also get the tail, which is giving me the rest of the elements. Okay, so list is a standard linked list. Head and tail, they are constant time operations, very fast. Then you can also take the first x elements from a list. So for instance, if I want to take the first 3 elements, I can get them by calling take 3. Okay, here you can also say take 3 like this. Obviously, this is matter of taste, whether you like to write it. I could take the 5 first elements. And at the same time, there is also the drop method that allows you to throw away elements at the beginning of the list and keep the rest of them. So drop 2 is removing the 2 first elements, and then you're keeping the rest of them. Good. So this is the more or less the normal methods. Then you also get the functional methods. So for instance, if I want to extract only the pair elements out of this list, I can do that very easily. So I can say filter, and to filter I have to provide a function. Okay, a function that is returning true or false, called a predicate. Okay, it has to take an int, so I can write it like this, int, and then returning true or false. So 2 here, and it should be equal to 0, right? And there we go, we only got the pair elements of this list back. We can simplify this a little bit. So this is a little bit clumsy of writing. So I could also specify this like this. And let's see, let's space it up a little bit. And this, we can do this because the compiler knows that L is a list of ints. Okay, therefore it takes the function that I'm providing to filter should be a function going from an int to a boolean. Okay, therefore I don't have to specify the type. I could also call map on this list. Okay, map is applying a function to each of the elements of the list and then returning a new collection with all of the results. So for instance here I could add 1 to it. Okay, so now I get back a list of all the elements, added 1 to them. Okay. Also notice that L is still the same here. I don't really modify anything. Okay. The list is immutable, and no modifications is happening. We're creating a copy of it every time. So this part here, I could also extract it. Okay. So this is a function. Functions are first-level citizens in Scala. Okay. Like they will hopefully be in Java 8 as well. Okay. Lambdas, if you like. So I can assign this to a variable, add 1. Okay, so here we got a problem that the compiler doesn't really know what type it is. So I have to specify that this should be an int, and in this case it will be okay. And now I can pass this method directly in here. Okay. What more? You can also group by. Group by. Yeah. Okay. Let's do something else. So lmap. And let's create a time. So Just first import Scala util random. Next int. Okay. Also, nice thing in Scala, you can write the imports wherever you want. So I create a new time with the hours. Okay, I used the elements of the list to create an hours. Oh, we have to filter first. So I have to extract all the elements that are less than 24. Less than 24. Okay. Okay, I can write this like this. Okay. And then afterwards I can map and I can create the next int. Okay, let's just create something between 0 and 10 here. Okay. Oops. Okay, so I got myself a list of times. And I can assign this to a variable. And now I can do my group by. So times, group by, and I want to group it by the number of minutes that is randomly calculated. Okay, and here I will get back a map from an int, which is the number of minutes. So we see that there is one element with our minutes equals to 0, one with minutes equals to 5, 1 to 6. Oh, no luck. Oh, 9. Perfect. That's good. Okay, so that's more or less a small preview of the Scala collection library. Do you have any questions to this? Yeah. The underscore, yes. So the underscore is a shorthand. Okay. If the compiler knows what types you're using, what type of the parameters are for your function, then you can use the underscore notation. Okay. So here I could specify the type of add1 to be a function from int to int. Okay. Okay. So this is just specifying what is the type of this function, and then afterwards I could simplify here. So I could write it like this. Okay, x becomes x plus 1, or since x is only used once, I can replace all of this with underscore plus 1. Okay, so in the beginning this might be a little bit like, ooh, why do you need this? But I think if you're starting to write a little bit Scala and you're starting to use it a little bit, it will come very naturally, and it's a feature that you wouldn't go without. I can promise you. Then afterwards, it's always a good idea to give good variable names, of course, but in this case, I think the code is quite readable, given you have seen this underscore notation before.
Do we have Scala code convention? Because you mix this object dot and object operator variable.
Yeah. So usually it's very limited when you can use the operator notation. Okay, being the one that we're using here without the dots. Okay, it can only be used when you're having exactly one parameter. Then afterwards, we are recommending to use it when you have a symbolic operator. You should always use it. Okay, so for instance, what I wrote earlier here, underscore dot plus like this. By Scala code convention, you don't do that. If it's symbolic, you avoid using it. Then afterwards, it depends a little bit on your personal preferences. As long as the method that if you're passing a function that doesn't have any side effects, we are saying that it's okay to use the operator notation. Okay. But that is something that you can define inside your organization as well.
Okay, but the convention, do we have Scala code convention to be our guide? Because I'm new to Java and I...
Yeah. So there is a Scala style guide it's handling many of these issues, how to write things, and there are a couple of corner cases where you can... you can do stupid things. So, well, it's nice. 10 minutes left. Okay. So there is the style guide, docs, scalalang.org, and somewhere here there should be a style guide. Guides, okay. Guides, overview, collection. Down here somewhere. Scala style guide. Okay. Yes. Good. So I had a time to do the time and the collections part. Maybe the last thing I want to do is, do you know the game of life? Yeah? I'm going to try to write a small implementation of the game of life in Scala. So the first thing I'm going to do here is to add a cell type. Okay. So let's just call it cell. And this cell, it should have two variables, so class parameters, x and y. And I'll make it a case class, so it will be easier to compare different classes. And basically the only thing that I need to know about this cell is its neighbors. Okay, I want to be able to calculate the neighbors of this cell. So this is all the cells that is surrounding it. Neighbors. What we can do here is to use a for comprehension. Okay, this is basically a for loop with some more power. And I can say that this should be the values from x minus 1 to x plus 1. And I want to turn this into a set. Let's not worry too much about that for the moment. And then I want to have the y's, and y minus 1 to y plus 1. Oops. And basically, if I want to return these values, I just say yield, and a cell with xx and yy. Okay. Now there's one problem here. I will also get the cell that I'm interested in, which is not a neighbor. So I can add an if here and say if not xx equals to x and yy is equal to y. Okay. Then afterwards, so this is giving us the basic things for creating this. We can create a second class, generation. And a generation in the game of life is basically all the alive cells that we have. So let's call it alive cells. And this can be a set of cells. Okay. And the one thing that we want to calculate here, it's the next generation. Okay, and the next generation is of type generation. Okay, and what do we need? We need the cells that can stay alive. So let's call them staying alive. And so let's make an implementation for this one. And then we have also newborn cells that can come in. Okay. So let's an implementation of this as well. Oops. Okay, so newborn, it should return a set of cells. And the same thing for staying alive. Okay. So let's start with, this should be a generation as well. And we need a new keyword. Plus plus is concatenating two collections. Okay, so it will add all the elements from one collection to the other one. Okay, so staying alive. What is it? What do we have to do here? If a cell wants to stay alive, basically it needs 2 or 3 alive neighbors. That's the condition for a cell to stay alive in the next generation. Okay, so that's what we have to calculate, whether it has 2 or 3 alive neighbors. Okay, and so when we're going to find all the cells that stays alive, we can start with the alive cells, and we can call this a function on each of them. So and this, and we filter out all the ones that can stay alive. Okay, so what is can stay alive? Oops. Okay, I'm going to try to define. Okay, no, wait. So can stay alive. It's a method from a cell, type cell, and it's returning a boolean. Okay. Since we don't have too much time, let's just keep it like this. And basically we have to count the neighbors of the cell that can stay alive. So alive neighbors. Okay, let's create this method of this cell. And the size of this has to be 2 or 3. And the way you can write this is set to 2 or 3. It should contain, yes, contains will return true or false, whether this is true or false. Then alive neighbors. So it's taking, it's a cell, and it's returning a set of cells. Okay. And basically, we can just look at the neighbors of this cell, and we can do intersection with all the alive cells that we had. Okay, you following? Okay, so this is basically what we need for finding all the cells that is staying alive. Okay, I think I still have a couple of minutes. Okay, then afterwards for the newborn cells, then we have to look at, so cells that can be born is by definition the cells that are not alive. Okay, so we have to find them, but as we know, the new cells, they can only come to life if they have exactly 3 neighbors that are alive. So the place we want to look here is in the alive cells. We want to call a flat map method on this. Flat map is basically like the map method that we saw a little bit earlier, just that you provide a function that is returning a collection, and then afterwards it's concatenating all these collections into one. So flat map, and we want to get the cells that, so we want to calculate the dead neighbors of this one. So let's create this method. Dead neighbors takes a cell, and it's returning a set of cells. Okay. And here we can do pretty much like we did earlier. So we say cell. We find all the neighbors to this cell. And instead of using the intersection, we can now use the diff, okay, which will give us the difference between the 2 collections. So, and we do the diff with the alive cells. Okay, but this will give us all the neighbors, so we have to filter out a little bit, and we can use that using the filter collection method. And we can say can stay alive. Okay, so this is the last little method that we need. Okay, so this will be a predicate again, taking a cell of type cell and returning a boolean. So this will be alive. Oh, sorry, can be born. Sorry. Can be born. Yes, that's better. You know, it's all this heat and this pressure, the time is running out, you know. I'm sure you know the feeling. The deadline is approaching. And we are calling alive cells on this, alive neighbors, okay? And we are counting the size of it. And actually the only thing we have to check is that the size of the alive neighbors for a dead cell has to be exactly 3. Normally this should be everything we need to make this code run. Okay, so I'm cheating a little bit. I don't have the time to implement the whole UI. Okay, but the code here is exactly the same as the one that is used here, and we see that you have like an oscillator or a glider here moving along, and this one is oscillating nicely while these one are staying alive like they want to. Okay, I think that's all that I have time for, and I guess the only thing left is to say thank you. I'm going to... The code is available